Okay, hi. So building desktop application with Electron. So the backstory of this talk is actually, this is not my day-to-day job. It's more like I wanted to explore how vast the JavaScript ecosystem is, and then I stumbled upon Electron and wanted to find a guide, wanted to find a tutorial to learn it. And funny thing, there's just nothing there. There's just tutorials that just start it up, copy-paste this code, that's it. And then I decided to learn it and write a guide. So it's based on that blog post. You'll have a link in the slides and later in the presentation notes and so on. So desktop applications, why? I've always loved desktop applications. They've always felt a little bit more powerful than web or mobile applications. They've got this certain integration with the operating system, and they're alt-tabbable, if that's a word. So, and they're always in your dock, they're always there. So they're great for building little utilities, but also building greater things, as we'll see shortly. So what's Electron? Electron is this framework, this platform that gives you the ability to use your knowledge that you already have of building web applications with HTML, CSS, and JavaScript, but with a very deep node integration, and to wrap it into a desktop application. It was made by the guys at GitHub, as they were releasing their own Atom text editor, and they released it at the same time with the editor, so they released a platform to build desktop applications, which is really cool. There are quite a few apps that are already built with it. Some bigger ones include the Atom text editor, Slack for Windows, the Mac app is built on another platform, Visual Studio Code from Microsoft, and Avocode, which is just nice. Atom text editor, I would recommend looking at the source code, because it's written in CoffeeScript, it's pretty readable, and all the good principles that you can use are going to be there. Today's talk isn't going to go too deep into the matter because it could last for hours, but I'd like to go over an overview how to work with Electron, its APIs and node modules that you can use with it, and how to package it for an end user and ship it. As already said, it's based on a blog post, so you can later click it and see the blog post. It's pretty detailed, and you get to build an awesome sound machine. That's like one of these things that you can get for an office, where you press something and then a sound comes, so like a fart or something like that. Yeah. And there's a accompanying GitHub repo where you can follow along pretty easily. So yeah, let's start with the overview. So a typical Electron app is going to be organized like this. You're going to have a main.js file with your app stashed somewhere else with your screens. Now, when I say screens, the application starts by running this Electron binary. You can download it and run it, or just use a package from npm, Electron prebuild, and it's going to give you for free for your platform and your CPU architecture. The application is really a series of browser windows running web apps, so it's really easy, and each window is instantiated by something called a main process. Now, what's a main process? A main process is something that Electron starts, and it runs this main.js. So yeah, Electron starts your main process, and each window that you start is started by a browser window module, and it's running its own renderer process. What's it got with these processes? Well, these processes make it possible for you to interact with the native UI, and they allow you to communicate between them. Now, the question is, how does such an application, how does its lifecycle look like? Well, there's another module for it, and it's all modules, I tell you. That's the app module that's available to the main process, and it's got a lot of useful events and methods that you can use to see where your app is at now. So how would something like this look in the main.js file? You would require it, and on various events you can do stuff. So when your app is ready, so Electron has gone through its whole initialization process, you can do stuff after it's ready. If you've closed all your windows, it would be pretty nice if the app also quit and not be left lingering somewhere in your memory. Now, okay, we've got it. We know how to start it. Let's see how to create a window. Creating a window uses another module. You guessed it, browser window module, which is very, very easy, but also very, very powerful in many useful events and many instance and class methods to see, for example, which browser window is right now active, if you've lost focus, if you gained focus, and so on. But to use it, it's really simple. You require it, typical Node Common.js pattern requirement, create a browser window, and load your web app from a URL. That's about it. Now you've got your window. We could actually end our talk here because you've got a window. You could load a calculator in it, give it to your grandma. That's it, fine by me. But it isn't a desktop app yet, even if it's running in a desktop window, if you're not interacting with the underlying operating system. How to do that? Electron is going to provide you the necessary modules, and not only Electron, but there's going to be also Node modules you'll be able to use. One thing that you have to always take into account, the Electron's modules are only allowed to be used from the main process, from the main.js, not the Windows. How to circumvent that? Of course, they already provided an answer to that. There are two modules that allow you to talk between the two between main and all the renderer processes, and they're called remote and IPC, and we'll get to them shortly. But first, let's get to the second point on our agenda, and that's Electron's API and Node modules. Well, Electron brings many modules. We already mentioned app and browser window and seen them in action, but also you can also, use existing Node modules that you can get in via npm as a package, or what's even more cool, write your own. Let's get to it. So let's start with this remote module. So remote and IPC are going to be the basis of your app because they're going to allow you to communicate between processes. So how does this remote module work? It's actually pretty easy. If you've got a renderer process from which you are not allowed to talk to the native UI, you're going to say to the main process, hey, give me one of your modules that I'm not allowed to use. Main process is going to get you a reference to that, and then you can call a method on it. It's actually, in the background, you are not making method calls to the browser window directly, you're making it remotely from the main process. In code, if you see the code, it's actually even easier. You require the remote module, and then you remotely require the browser window. Everything else is completely the same. Everything remotely smart happens in the background. Oh, remotely smart. Yeah. So that's the remote module. Pretty easy. If you want a more serious type of inter-process communication, so IPC, you're going to use the IPC module. It's also very easy. Everyone familiar with messaging channels and so on already knows it. So you've got a channel with a name. You take a process, subscribe to it, and every time someone sends a message on a channel with that name, he's going to get that message. Now, how does that look like in code? It's also pretty easy. You require the module. You subscribe to it by doing an IPC on with the name of the channel, and then you can send a message. It can be just like this, a blank message, which means you're just going to trigger this here listener, and then you can do something. That's a pretty nice way. Like here, when you send a message called close window, you don't actually need data. If you know that you want to close like a settings window, you can name your channel close settings window. But it can get complicated if you want to send data, if you want to reply, if you want to make synchronous, asynchronous messages, and so on. Here's a sample of an asynchronous message where you send also some data, you do something with the data, and then send a reply. It's also pretty easy, but it's powerful. There are, as I already said, quite a lot of modules, and I'd like to iterate through some of them just to see how vast that ecosystem also is. So a very interesting module is the global shortcut module. It allows you to bind your keyboard keys, shortcuts, to various actions. So it's a part of the Electron API. It comes bundled. And how does it actually look like? Once again, pretty easy. Require global shortcut and register it. Now, this here string is something that Electron calls accelerators. I have no idea why, but it sounds cool. So that's probably one of the reasons. You just write your keyboard combinations like this. The actually cool stuff about it is you can write all the special keys like media play, media pause, media next, and so on. So you can use your whole keyboard to use it. And of course, usage of a global shortcut module is obvious. Music players, you need it to play, pause when your application is not in front. Desktop screenshot apps, you need it to take a screenshot. All right. So very cool. Another cool feature is having a tray icon. And it's not only interesting because of the tray icon, it's interesting because it shows how several modules can work together. So let's take the tray module with the menu module, and both are, of course, Electron modules. And the tray module is going to create your tray icon. Then you're going to instance your menu and connect it to a tray icon. In practice, it's even easier. Tray require menu, do a tray icon, and you can also give the icon right there. Make a menu and set it as a context menu. Now, here this menu module is also pretty interesting because there are several ways you can make menus. This way, it's a template. What's a menu template? It's just an array of configuration objects. But there's also a module called menu item. So you can create many menu items and bind them to your menus programmatically. So it gets more and more powerful the more you dive deeper into the thing. Another interesting module is, let's say, clipboard to interact with your operating system's clipboard, a dialog where you can show nice alert messages or file open, file save dialogues. Then you got a power monitor that's really awesome because you get events that your laptop went to sleep or you went from AC to battery, which means you can make less requests and save the user some power. You have this power save blocker, which just means don't put my computer to sleep. And you can make your own, like these little utilities like a Caffeinate or something where you just don't want your download to break off. Screen where you can see if another display has been connected or not, if you want to set your app to another screen, and so on and so on. Here's also a link to all the APIs, to the whole API that Electron provides you with. Now, with all this knowledge in hand, it's not difficult to build quite a cool desktop application that features a lot of things that we await from a desktop application. But the question is, what now? Okay, we've run it. We've got, with this pre-built Electron package, we're running it at our computer, but it's no use if it's only running on my computer. So, sorry, I forgot to mention one cool, interesting module. That's the node notifier module. It's not part of the Electron API, and that's what's so cool about it, because you can use it anywhere you want. I've built a Jenkins notifier command line interface in the application for myself that connects to an instance of Jenkins, and each time the number of unstable job changes, it's going to notify me with a notification like that. To use it, I don't know if you can guess it, but it's easy. Require it, and its API is also pretty easy. So use it in your CLI apps, use it in Electron app, you can use it wherever you want. And the most powerful thing of all is you can write your own modules. In the blog post, if you visit it, you're going to see that I wrote my own module called configuration that just allows me to save and restore a configuration. It encapsulates some other modules. How do I use it then? I require it by path because it's not a part of the NPM, and just use it. The great thing about that is it's an ecosystem. If you write a great module, if you think it could help someone else, do submit it to NPM, and people are not going to say, oh, delete it. So that's pretty cool. Now, the packaging story, I'm going to get back to that, is you have to get your application somehow to your users. There is a bigger process where you do some zip files, something. It's, I wouldn't advise it because you have to package it for every targeted operating system, and it's a process. But there is an app for that, there's a package for that, Electron Packager. What it does, it allows you to do it pretty easily. You can use it from the command line interface, or you can use it directly from your JavaScript. So that means that you can very, very easily integrate it into your build process. And an example of that, it's very powerful. It's got many, many options. An example, it looks just like this. So you tell it where it is. It's a path. You tell it what the name of the app is. That's the directories that it's going to generate when generating your builds. This all switch is pretty cool because it replaces all your targeted platforms and CPU architectures. So it's Windows, Linux, Mac OS, and on 32-bit and 64-bit. So saves a lot of time. Version of Electron, where it should be placed, if it should rewrite previous applications, and of course, a nice icon. You have to have a nice icon for your app. That's more or less everything I wanted to say today, because diving deeper is actually a matter of getting your hands dirty. The API is huge. The list of node modules you can use is also huge. Any problem that you come across is probably going to be solved by diving into the API and reading the documentation. So I can only recommend you to check out the blog post and try to build yourself a sound machine. At the end, just like my colleague before, I wanted to say, yeah, that's the company I work for. I'm an Agile UX expert there. We do quite cool development. We've got lab skills. We learn lots of stuff in our company time. So, and yeah, if you like, apply. We always need good people. So yeah, that's about it. Thanks. Das Ding funktioniert nicht. Die Uhr funktioniert nicht. Ja.
Any questions?
So I just want to say, so I read your article a few days ago. I was looking into this Electron thing, and the article is really cool. It's really easy to follow, and I just built some sample play app. So please go take a look at it. But that's not what I wanted to ask. I couldn't find anywhere example about Polymer. So Polymer integrated into Electron. So some sort of a boilerplate or something. I found something Polymer and React, and it's not what I'm looking for. So that's one question. Do you know of something like that?
Yeah, unfortunately not, but I would guess that it shouldn't be that hard, because those are all web applications in the end. And it's probably more of a question of inter-process communication, how you manage to get those instances talking to each other and exchanging messages in a timely fashion and a normal fashion. And that's why I said check out the API. It's really huge. So only this browser module window has at least 20-30 events that you can listen for. It has where it has many instance and class methods that you can use, and these class methods give you everything you need for window management. So it's most probably just an issue of inter-process and between Windows management. Yeah.
One more, if I can. So the other question is, how do you do authentication with that? I mean, there's Node module, Node underneath, so your browser window is a regular browser window, and then there's your Node module that can talk to the internet, I guess. And how do you do something like authentication there? Like you pass credentials to the node and then it goes out, or how does that work?
Yeah, of course. Those are just web applications. So everything you know already applies. If you want to talk to a server for authentication, be my guest. You want to have a local database that starts with each instance of Electron, so your desktop applications. Very cool. This configuration module that I showed could be something like that. It's written so that it creates a JSON file in your user directory, so you can save settings there. You could have, let's say, an encrypted, encrypted document, a file that holds some authentication data. So every possibility is there. The framework is just so you get a nice desktop package, but your knowledge still applies.
That's cool.
Okay.
Last question. Knowledge is about browsers, and so I didn't catch which browser.
Chromium, sorry. Yeah, I should have said it. It's Chromium, and underneath is actually IO.js, not Node.js. But since 2 days ago, it doesn't matter because Node 4 merged those two together, so they finally found a path together. I didn't do it. Oh, okay, one more question.
Okay, last question.
Yeah.
Using the add-on, quite fond of it, but it's booting up very, very slow. Is that inherent to Electron, like doing some kind of startup things or whatever? That can take up to like more than 5 seconds, or 5 to 10 seconds if there is some modules installed.
I would say that's a typical problem of applications using plugins. Well, I know from, I use IntelliJ IDEA from my day-to-day work, and if I install plugins, and many of them, it's just really, really slow. So I would say that a blank atom text editor shouldn't take so long. But of course, there is some overhead. It's always better to, if you really need performance, then it's always better to write a native application. But if performance isn't such a big issue, it's just like the guys from React Native said, it's learn once, write everywhere. So the idea is to use your knowledge and write your application. If it's going to take longer, there are ways to optimize it, but I would guess it's a problem with probably too many plugins or a badly written plugin. That's something that can really bog the process down. Yeah, so.
Okay, thank you very much.
Okay, cool.